Thanks everybody for joining us today. Yeah, very much appreciated for joining us. So, did you guys have any veggie food? Yes, okay. I hope you guys are looking for veggie food. That's good. Yeah. Thanks, Sneaker, to sponsor us today. Yeah, to have the food, drink, and very importantly about the learning. We are going to learn a lot of stuff about the security today. So thanks for joining my Kubernetes Singapore meetup. So now we are growing bigger, and we are growing bigger and bigger. My name is Yong Kang Hee. I started the group from last September. So far, we're growing pretty big. Guess how many members now? Anybody has any idea? How many? 162? The members. No, I mean the total members. No, not yet. Hopefully soon. Okay. So far we already have 1,300 plus members. So in 6 months, we are growing very quick. Definitely thanks for everybody's support. And I know a lot of people love to learn Kubernetes. So that's why a lot of people join us today. So together with me, I got Han-Min. Han-Min is there, and also Kao-Yan. So shortly, I will hand over to Kao-Yan to talk about to do the introduction. So I only talk a little bit here. So welcome to join us. And we are continuously looking for volunteers, looking for speakers, and also sponsors. Okay. And since we are growing very quick and we are expanding, okay, I just created the Kubernetes Australia. So we're going to have the Kubernetes meetup in Australia as well. I actually just registered the account 1 week ago. So far, we got 63 members already. But feel free to take a screenshot and join us as well. If you guys join online, you can literally join anywhere. Okay. So guess how many people, the people join us from how many countries? Anybody take a guess? Surprisingly, I got 45 people, 45 countries. People from 45 countries join us. So because of people join us online, you can literally join anywhere, right? And typically after the event, I will share the slide deck and also share the recordings. That's why we have people from almost everywhere to join us. Again, thanks everybody for joining us. I'm going to hand it over to Kao-Yan to take it from here.
These are our volunteers who has been with us, supporting the events, even in participating. So this is our user group on LinkedIn. So I think like most of you are part of it, and in case you are not, you can join now. And for joining, like these are the links, like if you are very interested to become the volunteer or the speaker to join this group. So these are our links, so if you there is anyone like we want to share this presentation with us, okay, you can get this. So these are some of the events that like the participants are with the team here. So of course, So the topics which will be discussed today, the first one is task, the second one is some Kubernetes. So these are principles of which we engineer practicing. And later on, like it will be like later on, like thank you, everybody. So before that,
my headset. Otherwise, recording doesn't work. And the phone also doesn't work. I'm using this my headset. Yeah. Are you okay?
I don't have it.
No, no.
The next two sessions are at Google, and after that it will be at AWS, then F5. So other sessions like the
AirPods.
Yeah.
discount.
Yeah. No, they'll keep me, but I won't be able to hide.
You can keep it quiet.
Yeah.
Anyone want still to work on it? All right.
I would actually tell you a secret. All the later ideas. I always share you guys the slide deck and also take the screen.
So we will only put one mic with quality security. Okay, thank you. And
What do I need to do? So we're not sure. So I need to turn anything on or automatically do it?
Should be all right.
Okay.
Okay. Thank you very much. So I'm passing the session to Mr. Max. You can take on from here.
I won't need that. I can probably
Share
try
your
to talk.
screen. Share your screen.
Yeah, I'll share screen.
Yeah, feel free to grab some more things.
So there's a the person you want to ask is like so the expert will be looking at
We have a bottle opener. We have a bottle opener. All right, cool. Hello, everyone. I'm not going to use a microphone. Can you hear me well? Do I need to talk more? I've got these AirPods. Yeah, so I don't know why I've got them, but I can't hear you guys that well. But as long as you guys can hear me, that's the main thing. No, all good. Yeah, everyone reckons they can hear me, right? So, and this goes through the slides, does it? Once it's plugged in. Yeah, all good. So my name is Paz. I work at a company called Sneak. Has everyone heard of Sneak, apart from the fact that they're sponsoring this? Okay, so a fun fact around Sneak. So SMYK stands for So Now You Know. Did everyone know that? No. So one. And apart from a few of the Sneak people. So you've learned something already, right? But what we're going to do today is I'm going to talk about what we do Sneak from an AppSec perspective, but more importantly, what we do on Kubernetes. I have an Australian accent. Yeah. So I don't need this anymore. I still need this. Okay. Cool. Testing. All right, cool. This is better? Right. Yeah. My accent doesn't change when I'm talking into this, but All right, so as long as it works. One problem that I have though, I am going to show a demo. When I switch to a demo, I will not be able to use the microphone because I need to type in, right? So now you know what Sneak is. But what I'm going to do is I'm going to focus on app security from a Kubernetes perspective. So we do app security like throughout the whole software development lifecycle, but I'm going to focus on Kubernetes. But to do that, I need to talk and walk through an application lifecycle. So I've got an app, it gets containerized. Before it can run on Kubernetes, it has to get containerized, and then it runs on Kubernetes. And I'm going to show you what we do from an AppSec perspective, because sometimes there's a misinterpretation around AppSec on Kubernetes is a lot around runtime, and it definitely is. But what I'm going to talk about today is what can the developer do prior to the app going on Kubernetes, and what sort of feedback loop can they get while the app's running on Kubernetes. It's a nice thing. Yeah, but without a plugged in, will it? Yeah. So this doesn't work. I'm going to put that there. So the aim is something like this, guys. It's here is my code, secure it for me on the way to Kubernetes, right? Actually, our whole story is here is my code, secure it for me on the way to the cloud, right? Because this is a Kubernetes meetup, I've changed that to Kubernetes. So if you haven't heard of Sneak and this is your first time, we do have an AppSec platform that is built on, we use our own security intelligence database. We use sources from, National Vulnerability Database and others. And that source vulnerability database powers all those Sneak products. So the first one that I'm going to quickly touch on is Sneak code. That's the code that you write for your applications. That could be an API, that could be a web app. We scan that for security misconfigurations. We do the same thing with Sneak open source, because what happens is most people building applications now, we use open source libraries because it's just going to avoid having to write that low level code. And there's already a community and a whole heap of libraries. But again, that opens you up to a vulnerability perspective. The one that we're going to focus on a lot today is Sneak Container. That's where we're scanning container images directly in a registry or as they hit the Kubernetes cluster. But it's very important that you understand code and open source, because that's what makes its way into the container. So we need to go and scan and secure that, not just when we're building it, but also at runtime. So from a container perspective, we scan early on as the Docker file all the way into the Kubernetes cluster. And we're going to do that in the demo today. By the way, I'm only going to talk for half an hour. And believe me, it will be half an hour. So that's exactly how the talk's going to go, including a demo as well. So let's talk a little bit about Sneak Container. So from a container perspective, there's a couple of things you need to look at. The first one that we need to look at is when we are actually building a container, we build it from a base image. So sure, you can use multi-stage Docker files and actually go and build the container, test it, then go and actually use the last from command that actually builds the container. So what we want to do is automatically be able to scan that and provide a security posture from what Linux vulnerabilities you bring into the container. Then we want to be able to prioritize them. So even though you've got a bunch of vulnerabilities, you want to know whether or not those vulnerabilities are ones that you should be caring about. So the prioritization is really, really important. Otherwise, the developers are spending too much time fixing vulnerabilities that they potentially don't need to fix. The other thing we do with container is the open source artifacts make their way into the container. So whether you're building a Java app, we're going to use a Spring Boot Java app in this example, or whether you're building a Node app, the actual open source artifacts go into that application to actually run the application in the container. So as a result of that, we can scan that as well. And then we actually can scan the Docker file commands that you use to build a container. How many people actually use Docker files to build containers? Like everyone, or is it anyone use anything different? So everyone uses a Docker file, right? So there are other capabilities to actually build container images for you without the use of a Docker file. But here at Sneak, we assume that most people use Docker files, which is you've just told me now. So I'll show you how we scan the Docker file all the way into Kubernetes as well. So our Sneak Kubernetes development actually looks something like this. So we can actually scan what's happening in your repos before we even get to Kubernetes. So there we're looking at the open source manifest files. We're looking at the code files. We're also looking at that Docker file. The Docker file is the entry point to what the container is going to look like before it makes its way into Kubernetes. So Docker file it's the instruction file that writes to the container registry, and then Kubernetes picks up that container and runs it, right? So 3 steps that we need to do. And one of the first things that we do is we ensure that our customers build on the best base image possible. What do I mean by that? So let's say you're running a Node app, for example, and you might be using the Node 14.1 image, which is out there. There's many images. That one is potentially a little old, so there's more vulnerabilities. And so what we do is we scan that, tell you what the vulnerabilities are, and again, you'll see this in the demo. What are the more appropriate images you can choose to automatically remove a bunch of vulnerabilities and be already secure before you even fix any of those vulnerabilities. And then we continue to monitor the application while it's running on Kubernetes. So if you go from version 1 to version 2, where you deploy new workloads, our Kubernetes integration in Snyk will automatically pick up those containers and automatically scan them and add them to Snyk app. Right now, these are just slides. The reason I'm doing a demo so you can see this, and you will see this. In our platform, though, it's the only integration. So we integrate into all the source code managements, all the container registries, all the Kubernetes distributions, well, the popular ones anyway, not ECS, but I do like AWS, but not ECS, right? So, and so Kubernetes integration is the only integration on our platform that will automatically scan and pick up container images without manual intervention at all, right? So it's quite powerful from that perspective. And I mentioned about continuously monitoring applications. What does that mean? So if you deploy your app today and you've got version 1 running and it has 0 vulnerabilities, what do you think may happen 3 months from now? Anyone? One of the things that will happen is you'll need to continually scan it for 0-day vulnerabilities. They're just going to appear when they're ready to appear, and you'll need to know exactly what container images are using that 0-day vulnerability. Let's take Log4j, for example. And then you want to know which workloads are running in Kubernetes, which ones are customer facing, which ones should I be fixing. That's what we're doing in terms of continuously monitoring and protecting the workloads. The other one is you might choose the appropriate base image at the time of when you deployed the app. 3-6 months later, that base image may have more vulnerabilities that were unknown at the time, but now they're actually known, right? So that's what we mean by that. And last but not least, when you deploy an application onto Kubernetes, you set up a deployment config file, which could be a YAML file or a JSON file, for example, and you'll tell it how you want to deploy the application. I want 1 replica, I want to use this image, I want to set memory, CPU limits, etc. One of the things that is commonly overlooked is setting an actual security context object on the Kubernetes deployment. You get that wrong, Snyk will tell you exactly what you got wrong. So we're going to do that live. We're going to fix an app that wasn't deployed correctly. We're going to make some changes to the base image, and we're going to change the IAC config, and we're going to scan it prior to us actually going to fix it, and then we're going to fix it live on the Kubernetes cluster. So Snyk integration, container integration points is we have the ability to scan the Docker file in source code management. We also have IDE plugins in the CLI. So during the pipeline, you can run container scans, and the IDE plugin will also scan directly in the actual IDE itself, right? So it's quite powerful. Container registry is your next level. You've built the container, it sits in a registry, so we can scan anything, any container registry, either from the CLI or integrated into the platform directly. So I'm going to use Docker Hub in this example, but ultimately, if you've got a local Docker daemon running with a container built, we can scan there as well, right? So just anywhere where there's a registry for it to connect to, we can scan. And the one that we're really going to focus on is the Kubernetes cluster integration. And that's where you can set up an actual monitor that runs on Kubernetes, constantly looking for workloads, constantly scanning them, constantly providing remediation advice while your application is running on production. Again, the developer can do all this before he deploys his app, but ultimately the app's going to be deployed, and we want to continue to keep doing that. So this is a high-level Kubernetes integration, what it looks like. In simplest terms, the Kubernetes integration is a single deployment with 1 pod. That pod goes down, it restarts. It's not the end of the world. So no customer set it up with more than 1 replica. And all that pod does is one thing: talks to the Kube API and just finds out what workloads are running and auto imports them directly into Snyk app. And you're going to see that in the demo itself. And that's its job. And as the workload changes, re-import it. If the workload gets deleted, delete it from Sneak App. So all you're looking at in Sneak App, by the way, is our web-based portal. All you're seeing in Sneak App is currently what is running in Kubernetes. That's it, because your container registry is just a dumb blob store, the database. And you can have way, way more containers that are actually running in Kubernetes. So you need to know what you need to fix based on what's running in Kubernetes. Welcome. All right, so Sneak Container Live demo. This is going to kind of be hard with the microphone. So can I go without the microphone now? Yeah, this is a bit weird, but maybe you can hold it. Yeah. It doesn't matter who does it, is it? Now, what he's really saying is when he does his talk, I'll be doing the same thing.
That's fine.
So what I'm going to do is I'm going to jump into Sneak App here. So this is Sneak App. I've got a, can you hear me or it's not quite working?
Okay.
No, all good. I thought my voice was pretty loud, but clearly it's not, right? So this is Sneak App. It's got a bunch of what we call projects. So I'm just going to show you quickly the integrations. One of the integrations I'm going to show you is the source code management integration. I'm showing you that because that's our app, right? It's sitting inside GitHub. We also have integrations into cloud platforms such as AWS. I'm going to show you the integration into Docker Hub as well, and then I'm going to show you the integration into Kubernetes. I'll leave the rest out for now. We have multiple different integrations from the IDEs and so on and so forth. But just understand that we're going to look at the SCM integration through a Docker file. We're going to look at the container registry integration, which will be Docker Hub in this case, and then Kubernetes as well. We struggling with this setup or? Oh, cool, cool. Just let me know when you're done taking pictures and we'll continue. We're good? Yeah. All right, cool. So let's go to projects now. So what I've got here is a Spring Boot app. So what I'm going to do is I'm going to change the filters here and I'm just going to switch to GitHub only, right? So the app's called Sneak Boot Web. And if we look at it now, it's already scanned this repository. And there's obviously a bunch of different files in here. There's a pom.xml. Let's have a quick look at that, right? So that's our dependency management file. We've actually brought in a few vulnerabilities already. We do this deliberately, right? So one of them is log4j, for example. And you can see here, Sneak can actually give you the remediation advice and the ability to actually go and fix this vulnerability as well, right? So, and the IDE plugin, if I was to go from here, would also be able to run an open source scan. This is the same app running inside Intel, not running inside IntelliJ. Where is my pom.xml? So it scans this, and then you can even see that the log4j issue is shown here, and you get remediation advice here as well. What we're going to do is we're going to start, because we're here, we're at a Kubernetes meetup. Let's have a look at what we do with the Docker file itself, right? So we know we can do an open source scan. We know we can do a code scan, but let's have a look at the Docker file itself. So if I go to the Docker file, one thing you might want to note from the Docker file, if I've got it here, won't kill this or yep, cool. So from this Docker file, you can see it's really clear. I want to build this from using this tag here, right? The actual one that we're using for V1 is the one above, this one here. So it knows it's going to use OpenJDK 11-0.13.slimbuster. I've got a couple of different commands here that like adds a user, because I really don't want to run as root, right? You'll see why. And then I go and add my already compiled artifact. If you're using Spring Boot, you've already got the jar file. So why would you go and do it in the Docker file? Just go and add it, right? So it's already there. So that's cool. And the app is already, I mean, this has already been containerized in what we call V1, right? So let me show you a couple of things here in the, so one of the first things I want to do is just show you that we can run an SCA scan by just pointing directly to that pom.xml. And again, this is really similar to SCA stands for Software Composition Analysis. That is where we're looking at your open source manifest files, right? So you can see here, we've scanned, we've done license tests. These are all the vulnerabilities. The log4j one is somewhere in here. So if we do grep, oops. You can see why I've got an assistant now, right? Because I need two hands, right? So here you can see just the log4j issues, right? So that's the first thing we can do, and we can fix that. That's given us the remediation. We can also scan the container directly using Sneak Container Test. Now, for that to work, my local Docker daemon needs to be connected to my container registry, in this case, Docker Hub. So if I ran this one here, Again, everything's scripted. So we run this. This might take a little while, maybe 30 or so seconds. But what we're going to do is get a scan that actually looks something similar to this. So if I go back to here and go projects, this time now I want to see the already built container image. So I'm just going to go to Docker Hub. And you'll see here that when let's just turn off GitHub for a second. Sneak boot web, there it is. V1 is the tag, and it actually has done two scans here. It scanned directly into the open source artifacts that made their way within the image. So if I do this, I straight away see log4j in here, inside the container image now, right? It's gone and scanned the container image, and it also did the scan that you'd expect it to do, which is the scan of the actual base image itself. And when we look at that base image itself, we can see here that we actually auto detect that base image because it's an OCI image. It's not a text file. We auto detect that. We can see here, this is the current image. This is the number of vulnerabilities. And these are suggested alternative upgrades that can remove all our critical high and medium and just leave us with low vulnerabilities. And in fact, and this scan would probably finish now, this one down here. So you can see this is the scan results, open source, as well as the Linux vulnerabilities, as well as that remediation advice. So it's not just about scanning, it's giving you the remediation advice so you can use a more appropriate image. And if I went back to here and went to, just bring GitHub back in here for a second. And I go to this Sneak Boot web app and I just load the Docker file. It does that same scan, but this time it doesn't need to auto detect it because it's just a Docker file. So it already knows what the from tag is. But again, you get that same remediation. This time we can open a fixed pull request because we're in the context of SCM, in this case, GitHub, so that we can do that as well. What I'm going to do though is I'm going to deploy this application. So what we're going to do is go here. Yeah.
Okay, so you mentioned SCM before, which is like one of the key fund companies that we discussed with one today, about software supply chain and how to keep it, secure long term. What happens if one of the writers points of this package deployment that happens on Kubernetes changes or becomes vulnerable, day +1?
Yeah, so that's what we're going to do in the demo here today, right? I'm going to show you what that looks like. Yep, cool. Good question, everyone, as well. Well, someone needs to say good question because I didn't answer yet. All right, cool. So now what we're going to do is we're going to deploy this workload. And if I look at what we do when we deploy this workload, so we know it's got the log4j issue. We know we've got vulnerabilities with the base image, and we're going to deploy it anyway. But when I look at this deployment file here, which is what we call V1, a couple of things you may notice, like it's a really small deployment YAML file. That tells me one thing. There's no security context object in there, right? So that's clear. And then I'm accepting all the defaults, right? So I'm going to push this now. So I've got 3, deploy V1. Now, if I do a kubectl get pods in the namespace pairs, you'll see that string boot web has come up. Clearly, I've ran this multiple times in the cluster. Otherwise, it wouldn't come up that quick. And then what it's actually going to do here under projects, remember how I told you it's going to automatically import that workload? Well, it better do or we're in a bit of trouble, right? So I'm going to switch now to Kubernetes. So just give it a bit of time. So what happens here is this workload will eventually make its way into Sneak app. And the reason it's doing that is the monitor is actually running. You can see now here it's picked up Sneak Boot Web. And you can see here that when it did the scan, you can see that it did it a few seconds ago. It scanned into the container. It found the open source vulnerability. So nothing's changed here. This same app, I haven't made any changes, has the log4j vulnerability still in there. If I could type log4j properly. So that's still there. And you would have already seen from the container scan that we've already got the base image remediation advice as well. So if I go to this, and I go to this, and I go into here, which is the actual tag, we'll get that auto detecting advice that we already got. There's a reason for that. We haven't fixed anything yet, right? So you can do it, Sneak, come on. Maybe it's the Wi-Fi. Okay, cool. I'll just do a refresh on that. So from here now, when I go to Sneak Boot Web here, you'll see that when I scan this itself, it's the same scan that we did before in the container that was sitting in the registry. The reason that is, if we look at this, I'm pointing it to that container in the registry. That's the one that we scanned. All the monitor did, and if I was to actually go, if I was to do a command like this, you'll see that I'm going to get the pod, that single pod that is the monitor. Once I've got that, I can then do the logs, right? So if I do this and just run this, you'll see here that this is where it's picked up Sneak Boot Web here, right? And it's automatically scanned it. So I'm going to leave that running for a little bit. What I do want to show is one of the most important from an AppSec perspective is you now are open to the fact that a bad actor or a cyber criminal can actually come in through the ISC config. What do we mean by that? So if I go back to projects here and we go to Sneak Boot Web, how am I going for time?
You have 5 minutes.
No, I don't. I have more than that. Okay, good. Yeah, even I knew that, right? So here at this level here, I can still actually, you can see here the pairs is my namespace. It's a deployment and the app name is Sneak Boot Web. If I click on that, you'll notice one of the things that it's done as part of the scan is it's done this secure configuration scan. It's found that I didn't set CPU or memory limits. You saw that in the Kubernetes YAML file. I decided not to set a security context object, so it'll run by root default. That's okay until someone gets into the container, right? Then we're in trouble. The read-only file system has not been set, so you can read and write to this file system if you get in. Of course, you'll need to be root if you really want to write to it, but we've left that. And the one that this is one of my biggest fear is not actually dropping the Linux capability. So there's something like 128 or so Linux capabilities that are available. Someone gets into that container and you don't drop those Linux capabilities, they can go and do all these Linux commands, right? Sorry? Yeah, there's many more, right? So that's in there as well. The privileged stuff is there as well. So now I've got this app running. We know we need to fix a couple of things. So the first thing that we're going to go fix, I'm going to go to projects here, Spring Boot Web App. What I'm going to do is, I know that there's more appropriate base image here. So let's go rebuild. Maybe we'll choose this one here, right? So let's go and try this new base image. The app needs to run with that new base image, but at least we're going to cut half of our vulnerabilities. More importantly, we're going to cut the critical high and mediums and only be left with a bunch of lows, right? So to do that, I've got to go into my IDE here. I've got the Docker file. This is that new image that we're going to use here. For those that are wondering why I've got platform Linux AMD 64, that's because I'm on an M1. Believe me, if I didn't do that, it would never run on Kubernetes, just so we're clear. Until Kubernetes one day decides to support M1 chips, but that's not going to happen, right? So I'm going to rebuild this, but I'm going to use a script to do that. So I'm just going to say, what is the script? I should know the script. So it's build container. So I'm going to say build container. Oops, not in there. I'm going to say build container, and I want to build a V2 of this container. This time I'm using a new base image, right? So we're going to build that. Why don't I have Docker daemon running? That is weird. That is really weird. Sorry, guys. If I go to application. I know why, because I decided to reboot. Do you remember?
Yeah.
And the reboot didn't help. Do you remember? Yeah. So I just got to wait for Docker to come up now. Hopefully not too long. The reason I need to do that is because I need to rebuild the image and I need a local Docker desktop running. So hopefully that starts up soon enough. You can do it Docker desktop. Cool. I think it's done it now. So let's just do build container V2. Cool. So I've switched to a new base image and now it's rebuilding that. And yes, you know, as Kubernetes enthusiasts, you'll know that when you build a container, there's various different layers. What's changing here is the layer for the base image that I've determined. That was really quick. Anyone want to know why that was really quick? Because normally when you build an image, it takes minutes. Anyone want to know why? Why was that so quick? It had nothing to do with Kubernetes. Yes, because I've built it so many times that, yeah, even the cache knows what I'm doing before I type it in, right? So now we've got a new image. What I'm going to do now is I'm going to deploy that. So if I go to this deployment here with security fixes, the only difference here is now I use V2 of the app, but this time I actually set some CPU memory limits and I set a security context here, right? So let's go and push that. To do that, we go and run V2. Yep, so 6. Deploy V2. Now, normally what I would do is a rolling update and go from V1 to V2, but in the context of explaining AppSec and what we do at Sneak is I've left that other app still running there, right? So if I do a kubectl get pods, pairs, now we'll see we've got 2 Sneak Boot Web with that unique name that Kubernetes has to give every object that no one knows, right? And V2 is the new one that's running. So now hopefully the monitor has picked that up. So you can see here the monitor, I've just did a few returns here, has picked up V2. It needs to scan it. When it's scanned, it has to send the results back to Sneak Up. That's the job of the monitor. The monitor that's sitting in the Kubernetes cluster is connected to Sneak. He's picking up these workloads as they hit the cluster. So if I go to here now and do projects, you should see V2 has appeared now. So I'm only looking from a Kubernetes perspective. You'll notice how it's only done the open source scan. So if I did a reload now, still waiting for that to do it. So eventually that one's going to come. I need it to come, otherwise I can't show you what it's going to do next. So let's do a hopefully we get 2 scans now. We've still only got 1. That's interesting. For those that thought this wasn't a live demo, it is. So what I am going to do is go and delete that kubectl delete -f. I'm going to delete this one with the security fixes. And what you'll notice here, if I do a kubectl get pods, it's actually gone now. And then hopefully, this is part of the auto importing and auto deletion, which is what the monitor does. So the V2 has now disappeared. I'm going to deploy it again because I wasn't really sure why it didn't pick up the actual base image. So we'll just run this command. Going with time, probably another couple of minutes. 4 minutes, cool, okay. So hopefully this monitor now decides to actually pick up the V2. So it's still only done 1 image count, which is interesting. They're still waiting to pick up V2. We'll just leave that for a sec. What I want to show here is that these IAC scans can actually also be done using Sneak IAC tests. So if we look at this V1 here, we just had all those different IAC issues, the initial app that we deployed. I'm now using the IAC test. And by the way, this stuff is also done in the IDE as well. So when I go to Sneak here, you can see that it's picking up those configuration files sitting here as well and doing these IAC scans and looking for whether I've dropped Linux capabilities, all that stuff that I've already showed. And this IAC test here just gives me a nice summary of all those issues that we saw with the V1 app itself, right? So hopefully now this picked up and I get 2 here. If I just do a reload here. V2, and do I have 2? Right, cool. Not sure what happened there. So what you'll notice though is a couple of things change here. So I rebuilt the image with V2 and a new image, new base image. So if I go to that first, you'll see that the first thing it tells me is this is up to date. There actually are 40 vulnerabilities still, right? So the issues 43. But if you look at most of these low issues, they have an exploit maturity or not. It's not exploitable. So it's kind of safe to leave it. What you want to know is that this is constantly being monitored. If any of these become critical or high, you can then select the more appropriate base image to fix it. So hopefully you're getting a theme for what app security and Sneak does on Kubernetes. We're not doing any runtimes. Is anyone SSH'd into the VM, gone into the container image, deleted a file? We don't do any of that, right? That's pure runtime and auditing that happens. CSIG and other companies do that sort of stuff. But you'll notice that we've fixed that. But the other thing, and I'm going to finish right on time, right? So if I go to V2 this time and click on this, you'll see now that all of these have passed, right? So part of this demo was to kind of highlight the fact that as workloads are hitting the Kubernetes cluster, so thank you for that. Yeah. As part of hitting the Kubernetes cluster, we're checking the IAC config, we're checking for base image and open source vulnerabilities. So what I didn't do was fix the open source vulnerabilities, but I should have. But I fixed the base image and I also fixed the IAC config. And you'll see that the monitor that's running on the Kubernetes cluster is just constantly scanning those. Not sure what that noise is. Oh, cool. I hope they enjoy that coffee. So yeah, that's the end of the demo itself. I just wanted to finish with a couple of extra slides here. We're running a live demo cast. Oops, I need to share that. Is that sharing? Yeah, so I'm running a live demo class. We actually go through the whole Sneak platform. I think we're going to share these slides, correct? Yeah, so the demo cast goes into the full platform, policy management, scanning, cloud. It does a little bit of Kubernetes, but a lot more. So you're welcome to join that. 30 minutes, really, really fast. And if you really want to get hands-on with the Sneak platform, I'm also running a live workshop. What I mean by that is you come into a Zoom call and you sign up for a Sneak account, a free one, and you'll be doing open source scans, container scans, ISC scans, and code scans. We didn't look at that today, the ability to scan your actual code as well, right, through a workshop. So very easy to join that and be part of that. So I'm doing that one as well online. So any questions before we pass over to my friends at AWS? Yeah.
So let's say the basic investigation that Kubernetes acceleration. What if I randomly go into
So what you're really saying here is, what if I fix those vulnerabilities within? So you pull down that base image, fix it, reload it into your registry, and use that as your base image. Which I'll be honest, not a lot of people do, because normally just choosing a more appropriate base image, it already increases their security posture. But what will happen is, if you fixed all those 43 issues, you won't see them there, because we've scanned it and determined that they've been fixed. Does that make sense?
So this is not based on layers that they but
yeah, so even so, it's fine. So it knows the vulnerabilities in the list and then double checks if they're still there. No one's fixed them at the moment in the base image. Yeah. It is when it shows me all the vulnerability lists, but when it scans and tells me that these are my issues, which was below, if they've already been fixed, they won't be showed there. Just the high level will show up. Does that make sense? Yeah. You're going to have to come up, but yeah. So that I can answer your question. Yeah.
Actually, I would like to say something to the people. Before deploying an empty scanner, if there is anything vulnerable in my deployment, any of it, I want to block that deployment. I don't want to release it. So is there a possibility something like an application controller can be maybe or something? Can we do something like that? Can we block the deployment?
So you can, but we don't have what you call a mission controller, right? But what we do is, in a pipeline, when you're deploying your app, when you do the IAC scan or the container scan, you can set the severity threshold to say, if I've got any critical or high, I'm going to block this build from continuing, right? Yeah, yes, correct. And at the moment, I do get this asked a lot. Can you create some sort of mission control that not only tells me about all these issues, but blocks deployments? But to do that,
we need to install that on Kubernetes, right? So it's something we're thinking about. We haven't yet. It's planned, but not quite. I think it's a good question. Very good. Thank you. Any more questions?
Thanks for the talk. If I want to use do I deploy it on my cluster? Do I sign up for the account? If you don't want to wait for the workshop?
Yeah. Well,
good question number 2. Right. So yeah, you can go to Seek Apps, so app.seek.io, and register for a free account. To test the Kubernetes integration, and that's part of our enterprise. So what that means is you can't do it unless you purchase, right? So that's good. You can see the capability of what you can do as part of our enterprise, right? But you can sign up for free without going to my workshop and go and play around with things, right? Is it pay as you go, or is it like you need to talk to one enterprise license? Enterprise you definitely be talking to Sleep. There is a Teams plan for like 5 or so developers you can do start using credit card for. But the free plan will give you a certain amount of scans for free anyway. Okay, cool. And you can run container scan, ISC, open source without paying. Awesome. Okay. Any more questions? Yeah, hi. So in case if I'm using a Gradle zip up or out of
yeah, just need to pop.
instead of using Gradle zip instead of the Docker file, so is it possible to integrate sync with that?
Yeah, it is. So when I spoke before about is everyone using Docker files, and put your hand up if you're not, no one did. That's an example of where you maybe build packs, there's others, right? That actually build the container images
from source code itself. We still scan that, we'll still scan the base image and tell you about the vulnerability. Yeah. In fact, that's the smartest way to build container images because they're updated automatically. Right? So you're already increasing securing your base images without you doing any work. You're constantly updating that layer. Yeah.
Any more questions? Okay. I passing this to the next speaker, the CEO.
Thank you.
Mhm. Thanks, Paz. Good session, right? Yeah. Yeah, I think you guys learned a lot of stuff. My next speaker, Leo, actually, he's also an expert in the security part.
So he says, like, I don't know. Yeah. I'm Australian actually, but I was born in South America. My accent is not as strong. Can I not use the mic? Is it okay? Is all right? Cool. Let's go. Let's go. Yeah. I'm a Brazilian born Australian, so not as sick, I would say. Yeah, exactly. And I almost speak English lah. You know, I've been here for a while. So good evening to you all. My name is, I don't know why it's changing, but it shouldn't be changing. What is going on here? I love Zoom, as you can see, we all do. I'll just leave it here. My name is Leo da Silva. I'm a security specialist, I say, with AWS. I've been with the org for almost 3 years, which sounds like a really long tenure these days, just in the same company, but I'm still enjoying and still having fun. In my role, I work with customers in Singapore, mainly enterprise and large SMB accounts, as we call it. My specialty, my expertise is in application security. But because, of course, we had Sneak here, which is our dear partner, and we work a lot with Sneak. I have a free account. Sorry to tell you this. I don't pay for it. I use the free one. Good, next slide. Stay tuned. Stay tuned. So yeah, we would have like Sneak coming in and presenting application security. So you see, like, it's crazy. I'm not even touching. I'm away from my keyboard. I think I got hacked. Something happened. I'll try again. Someone is controlling my computer. Look, it's absolutely nuts. I'm clicking to go back, and anyway, just leave it here. So I decided not to go on application security again. And I'm stepping outside my comfort zone to talk about cluster security on EKS deployments, which, by the way, is one of the key areas that our customers engage us with. They go, I want to use Kubernetes in AWS. I think it's a really cool feature. And I just don't know how to secure my environment. And of course, our conversations come from, let's create a pipeline and let's put Sneak to scan all your images and make sure that we have, securing the supply chain applied. And we have all the, SAST, SCA, code scan during runtime, all those bells and whistles. But what about the clusters? What about the nodes? What about the etcd node? What about worker nodes and master node, and you name it? Of course, with AWS, you see again by itself. No, like I didn't. Anyway, it's a show. I'm doing a show already. So of course, all those challenges that we all know of, and we should know about it, right? If you don't, and you're dealing with Kubernetes in production, I feel for you. I'm sorry to hear that. You should know that it's not easy. It's complex. It's by default insecure. I'm just putting it out there, right? That's it. Whether you like it or not to hear it, deploying applications in Kubernetes, no matter which flavor you're talking about, if you don't know what you're doing, chances are you're gonna end up in a bad position, right? So let's get together. And I love this user group because it gives a little focus on something that everybody uses it, but I think there's not enough traction in the market to actually discuss some of the best practices in the industry to make us all look better to our managers and our business stakeholders, right? So I'm not going to cover any of the application stuff that our Sneak folks just covered before. I'm going to be talking about cluster security. Of course, this is part of a defense in depth approach. By the way, I forgot to mention before, even though I'm an AWS employee, I do not represent my employer's point of view. This is my own personal opinion about everything that we do, and I'm obliged to say this before any public speaking opportunity, so apologies for that. So continuing that, so defense in depth is something that we discussed over and over again. You cannot tackle things on an isolated basis. You have to look at the whole spectrum of controls that should be applied, all the way from the host to the data that's being manipulated, stored in your application or database, right? And that is applicable to Kubernetes, traditional applications, deployment on EC2 instance, it doesn't really matter. Of course, the context here is Kubernetes. Same principles applicable, right? If in Kubernetes, and I'm not gonna be doing any sales pitch here, I just wanna clarify something. AKS has different flavors, even though Kubernetes orchestration platform is the same. The way you deploy that inside AWS changes and varies. It becomes a little bit based on your approach and your appetite to control the workloads underneath that. If you want to have full control to the nodes, you have to go with self-managed nodes, which means you're going to have a whole bunch of EC2 instances on the platform. The second flavor that you have is when you have managed node groups, which means AWS takes care of some components of that environment, but ultimately it's still on you. And the last flavor is EKS Fargate. In all fairness, and that's why I had to say before that I don't represent the opinions of my company here. In all fairness, this is probably the least used variation of this deployment. Because normally when customers go with Fargate, they go with ECS, not with EKS. And that's my observation. And that's probably because when they use EKS and not a distribution from the provider, they want to have more control over the entire stack. So it kind of, in my head, they don't match. If you want to have control, but you want to offload all the compute to your provider, it's kind of, yeah. If that's your approach, go with ECS. Honestly, don't even use EKS, but the option is there. Okay, so the first thing I want to mention around the cluster security and how we offer best practices to improve the security controls in your cluster environment. First things first, I'm not sure if anyone, actually, let me ask this question. Anyone here has ever deployed EKS? Yay, thank you. Few hands, awesome. You should try, it's pretty cool. I think there's a free tier for EKS, I'm not too sure. I don't pay my AWS bill, which is good. So basically, one of the key mistakes that I see customers doing, and it's crazy to even think about it, but let's assume you are this person here and you go to your organization and you deploy a new EKS cluster and you create a role for that deployment. What do you think happens when you, after deploying the EKS cluster, you remove the role that you use to deploy the EKS cluster? Again, role is IAM, cluster is being deployed. What do you think happens if you remove the role? You have to destroy the cluster. And that's one of the contradicting features in security, right? You are actually trying to do something more secure, but you are you're stopping the usage of that resource because it was not designed correctly. Every time you use a role to deploy an EKS cluster, that role becomes the master account within the EKS cluster. Always remember that. Even if you want to remove that role after or disable the role afterwards, you have to create admin level roles and apply to the RBAC model within EKS before you can remove the role. Was that clear? I can repeat that. Clear? Cool. So basically, every time you create a role, every time you deploy a cluster, sorry, your first action should be creating a IAM role that will be mapped to a EKS admin role. And of course, you can assign those roles to different users. Hopefully, you're not using IAM users. You're using credentials and roles to assign permissions to your cluster. And then after that, you can remove the cluster builder role if that's what you want. or at least suspend the role. Of course, all those permissions should be listed in your JSON policy file within IAM. I can share with you the different permissions required, like list nodes and create instances and whatnot. There's like 5 or 6 different permissions required. If you're interested in that for a least privileged role-based access control, I can share that permission file with you. Of course, as I said before, after you deploy your cluster, you create the roles mapped to different RBAC models that you might have. You might have a dev role, an admin role, a security role. Knock yourself out, but at least admin role should be created straight away, right? And only after that, you can disable or remove the role used to create the cluster. Are we all good with that? Cool. So next, let's talk about client authorization and authentication. I think I briefly mentioned before, like not using IAM users. That's our best practice, even though it's supported. You can do that if that's what you want, but it's not really scalable. It operationally is a lot more complex than when we have like identity providers. And by identity providers, I mean your own identity today, or you can have like a built for purpose identity using Cognito, which is our solution, or even like one that you create. I don't really care. As long as it's manageable, long-term and at scale, go for it. IAM users are not your best friend in this case, right? So I suggest you to use service accounts with tokens that can be issued, especially if you're trying to assume roles cross-account. I'm not sure you're gonna have time to go over STS and cross-account access here for this sort of things, but that is one of the key principles of security and identity and access management inside AWS using native resources, is to use roles and cross-account access based on STS tokens. Am I saying something really foreign here? Does anyone not know what STS means? I'm happy to explain quickly. Awesome. We are all AWS experts in this room. I'm surrounded by SMEs, which is great. Of course, EKS will rely on the native Kubernetes authentication process, authorization process, sorry, with the RBAC that belongs to the Kubernetes cluster. AWS can map roles to the RBAC model, but it's controlled by Kubernetes. And that is one of the beauties of leveraging EKS instead of ECS. ECS is our own version of it. It's container service, elastic container service. That is kind of the flow of IAM authentication using EKS on AWS. Of course, we have different services that are. I'm happy to share this deck with all of you after that. This is mine. This is not AWS, so I can share this with you. Basically, all those different flows here and arrows that you can see on the screen, they are kicked off by this guy here, which is your authentication mechanism. You're going to have some IAM credentials, right? Some tokens, OIC or SAML, whatever the protocol is standard you decide to use. And after that creates an authentication token within AWS. Everything else happens, right? So one of the best practices for authentication in that case is to follow all the industry standards to, apply MFA and apply a password policy if you have to use password. If it's a service account, use MTLS in a lot of cases, leverage ACM, leverage a KMS for strings and authentication based on that. So there's different ways you can achieve that result, but ultimately you have to generate credentials to get the token to assign against EKS, right? There's a flow you have to follow. I'm assuming here your identity is already sorted out. I'm not going to be discussing this here. It's all about issuing that token using STS to log into EKS, right? And for this, we're talking about OS level access as well as containers running on top of it. Back to the RBAC principle, we're going to be mapping those credentials to different roles within EKS. So quick list of best practices on EKS and roles within identity access management, which is our service, of course. I'm not going to be repeating myself, but a whole bunch of them, and there's more. Those are the key ones, but there's a lot more that we can use to provide this authentication mechanism and authorization mechanism for different credentials to your EKS cluster. Any questions? let's try to make this more engaging, guys. I don't want to have a monologue here. Ask me some questions.
I really have one question.
I asked you a couple of questions. Yeah, you're a terrible assistant. You're fired. Yeah. ECS? I honestly, yeah. No, it's not. It's not. The answer is simple. Never.
Is it because the platform itself runs ECS as a core component?
No. No. It's based on my personal experience that we have probably 25,000 times more ECS customers than EKS. Like not even close. Not even close.
So you think if that even changes, then they'll rebook it?
I think if I had to bet, we're gonna get rid of EKS before we get rid of ECS. No, it wasn't. Keep trying. Nah, I think we are gonna have both, honestly, because they actually fit different needs. More mature organizations, they go for EKS, but some of them actually go back and change it. They only have EKS for specific workloads. For dev or even UAT or for small app stacks, they go ECS because it's easier to manage. EKS requires a lot more operational procedures than ECS. Sure. 100%.
The answer I want to hear is just go to larger than
Yeah. Yeah, no, great question. And I love to answer those questions in front of my partner. I do. Of course, AWS platform offers native capabilities for a whole bunch of checks that we do. Even for statistical analysis, for dynamic analysis, SCA, we do all that natively. Is it as good as what Snyk does and the way Snyk does? No, it's not. I think there's a lot of capabilities and features that third-party tools like Snyk bring to the table that we don't even plan to have. It's not even the position that we're taking in the market. We do have those point solutions to kind of complement whatever controls you want to try and you want to experiment with. But every single mature organization that is investing time and money in security, especially application security in the pipeline, you rarely see them adopting native capabilities, and not just AWS. You go Azure and Google. My experience, they always go the next level with the likes of Snyk.
You want me to ask questions?
Go for it.
So
Can I just have a pause in my time because no, go.
No.
No, go.
Yes, or EKS, you spoke
Uh-huh.
about stuff. Are you finding that you have customers that just roll their own Kubernetes, even though you can manage it on AWS, like maybe using cluster API? You see
No.
see that?
No, I don't. And no. And even though Kubernetes native API control plane is a lot richer than whatever AKS offers, not even close, like custom resource definition and a whole bunch of other things that you can manage using Kubernetes native APIs that you can't with our control plane. It's not compelling enough for them to adopt that. But that's my personal experience. Again, I'm talking about my personal point of view. Maybe if you go to the EKS specialists in the rest, they're gonna go, "You're crazy. We have like 30% of our fleets are Kubernetes native." I don't know. I'm not seeing it. Not in Singapore. Not for large enterprises.
I'm done with the question.
Cool. Thank you. Any other question? Yeah, go. More application security, the same. Exactly the same. EKS on EC2. if you have to have a scale, right, from the least amount of operational effort to the highest amount of operational effort, ECS Fargate is here, EKS and EC2 is here. It's not even close. It's not even close. No, it's different ballpark. Who said no? Okay. I don't know. I won't pretend to know the answer. I don't know. And my gut feel tells me that it will be ECS Fargate is not for every single use case of application. If you have like a super chatty, stateful database connected all the time kind of application, I don't imagine you picking Fargate as your platform. But that's my point of view. Maybe it works the same way, but I don't see that happening often. Like Fargate's more for like stateless applications, microservice coordination, like API-driven access. Like when you have an API gateway and you want to have some business logic outside the gateway, you just go Fargate because it's like super quick. You don't have to right size anything. You don't have to do any kind of pre-configuration of compute layer. It's just like deploy, run, that's it. Short-lived, ephemeral. That's more like the use case. But in terms of latency and performance, I don't know. Maybe there's some benchmark somewhere. I just don't have access to it. I'm not a container specialist. I'm not a Kubernetes specialist. I'm a security specialist. So in terms of securing your containers, is exactly the same. Because after you do all your unique, checks and balances and have like the end of the pipeline, the target deployment, it doesn't really matter. You should be doing everything before it even hits the platform, right? And then the runtime security, different story. Yeah, shift left is a thing in the industry, right? Everybody keeps saying they should shift everything left. But as a matter of fact, there's a lot of vendors now hinting that we should go back to right. And I'm confused. Like as a consumer, I was like, where should I go? So the answer is like security should be throughout the pipeline. It's holistic. If you just push everything to the left, you're going to be missing something. Runtime is all the way to the right. How do you secure that? So those questions are yet to be answered. In kind of any what, sorry? Heaps, lots of it. The most common privilege escalations on the workload. So misconfigured containers that will allow RCE conditions so people can assume control of the host that is running the container. That's by far in my experience, by far the most serious incidents that we see. And that's beyond AWS. That's even my time as a user all the time.
Just following up on that question. So in that case, investigating for such cases, maybe something.
No, it's container. Because remember, let me go back. I didn't want to call application security. Where is Paz? Where is he? Oh, okay. Here it is. I'm answering questions about application security here because you're not around. It should be. Now they were asking what sort of incidents I'm seeing happening on EKS, and the follow-up question was,
in the event, let's say there's a container compromises, so investigation would it be similar to
how to investigate incidents on EKS if it's similar EKS on EC2, right?
Yes. To answer the question, which I know I can't, we will scan the container from the container registry and show you vulnerability with the IC config. From an ECS perspective, we don't do that, but I think your question is more around compromise container live at runtime, yeah, which is what we don't.
You don't. Okay. So in our case, I can quickly answer this question. We do have a service that monitors suspicious behavior during runtime for EKS. So it's not necessarily a container runtime security, because by definition, that's a different control, right? So what I'm saying is we have a service that monitors logs like VPC for logs and EC2 logs and application logs and whatnot. And if there's something that deviates from what we believe, it's a machine learning powered solution, right? If there's something that deviates from that standard, we go like, hey, there's something suspicious here, you better have a look. And that's our container runtime security control. That's not really applied at the container level, it's at the host level for EKS. It's node. Yeah, it's a node. But we kind of capture container logs if you're pumping everything to CloudWatch, right? Because it's part of the ecosystem. The most important, those statements, here you go, a man of your word. The most important, I truly, strongly believe, is the application security within your container. That is the most important part. Your EKS nodes, the OS that's being shared between the different pods and containers there, if you are serious enough and you're using like a good provider, they are hardened already. So it should be controlling what goes inside the container on top of your nodes. Exactly. That is probably, if I had to pick one, I'll pick that. But again, security defense in depth, you have to look at the entire chain, right? I went back all the way to the start of, I won't start again, I promise. I just want to show you, I just want to show you this, like, you see, like processes running on a shared host. This is one of the key items about the RC conditions and privilege escalation and control of the node that's running that's number one by far. And also like when communication from container to container that does not run over MTLS can actually be leaked as well, depending on how you architect that flow. Where was I? I think I was here, right? Yeah, I was here. So this is what I mentioned just a little while ago. We do have a way to analyze control plane logs with AWS. If you're leveraging a service called GuardDuty, because GuardDuty looks at the logs that go from Route 53, VPC for logs, what else? CloudWatch, of course, CloudTrail, and a whole bunch of them, right? They end up going to a CloudWatch data lake if you want, and then GuardDuty can consume all the data sources and detect any suspicious behavior within your pod and say, hey, do something about it. The key thing here is to have the logs being funneled to the right, destination. Lots of applications don't have meaningful logs to be shared. Therefore, it's hard to detect if something goes wrong. Of course, EKS control plane would have it, but that's just part of the, the whole equation. You have to look at, host, control plane, application. All of them will give you the full picture of what's going on in there. But we do support that natively in AWS. Of course, all the audit logs, every single API call that's made within AWS generates a CloudTrail event. And that is important to keep audit information from management, from your operations. And of course, can give you a lot of insights about how your users and administrators are consuming that service. So one of the best practices is to have dedicated S3 bucket sitting in a separate account, if possible, with all the audit trails coming from EKS. And you can set up some Athena queries like native, I think it's like probably almost free. Athena, which is like a SQL query that you can run and scan an S3 bucket content and get some insights from it. It's super cheap, right? How are we going for time? Are we still good for time? I don't know. I'm not controlling. Anyone coffee? I have 5 more minutes. Cool, thanks. So yeah, just quickly showing like how GuardDuty is deployed. GuardDuty is centralized. You can centralize, of course, in your security account, but you have to deploy GuardDuty in every single account that's hosted in EKS cluster. It does not mean that it's going to increase price. It's the same price point. It's just the way you distribute that. And the reason being, if you are doing the right thing for your EKS deployments. You are establishing different accounts for different EKS environments and stages of deployment. So for your production cluster, they sit on a different account than your development cluster, staging cluster, and whatnot. Different accounts, not different VPCs, different accounts. That's our best practice, right? So please make use of it. I'm not sure if I'm going to have time to cover everything, but let's see. Oh yeah. Security groups for pods and worker nodes. Because EKS is deployed on top of EC2 instances, the same principles of any VPC-based resource is applicable. Lots of customers, lots of people deploying EKS, they forget about security groups native to the subnet where EKS is deployed. Security group is a friend. It's there, it's free of charge. There's no cost associated with that. Just use it. Just make sure that you are combining traffic from pod to pod also through security groups. And if there's anything traversing the VPC, make use of NACLs, Network Access Control Lists. They are your friends. Stateful and stateless, I'm not going to be able. Anyone here doesn't know that? Oh, we are good. Okay. So NACLs, stateless, security groups, stateful, make use of it because they can help you control, especially if your services are using private link and VPC endpoints, control them using security groups. These are best practice and a lot of people forget about it. I'm gonna just leave some key resources here as well. One of the first link there is a really sort of comprehensive guide around EKS security and how we can enhance that. Pretty much focus on infrastructure. If you want to know more about the application security, I can share some other resources after that. But if you want to know more about how to improve security on your cluster, that is probably the best link you can find in AWS. Last but not least, just self-promotion, 10 seconds. So there's a ASEAN summit happening May 4th, if I'm not wrong. I'm going to be presenting there. I have one of the sessions. It's free, just register, just go. Lots of fun. And also Reinforce happening in California in June. It's our main security conference, AWS annually. Yeah, if you have a chance to go, let me know. We can have a beer or two. No, nothing special. Yeah, I'll be there. Just let me know. Cool. Any last minute questions? I think I ran out of time anyway. Go.
Thanks everybody. Yeah, if you guys don't mind, come forward up and let's take a group.